Let's do a couple more examples just to help us understand how to do this whole pattern matching thing. So here we have our string as ttt.000 and the t's are capitalized, and we're trying to see if it matches the pattern star dot star. We see this is true. Why is this true? Well, let's look at our pattern and see what we're trying to do. We know we have a dot. The pattern says there must be a dot in the string. And then we can see that there could be any number of characters before the dot, or there could be no characters, and there could be 0 or more characters after the dot. So as long as our string meets that pattern, we're good. So first, we gotta first ask, is there a dot in our string? The answer is yes, there is a dot. So that means that we can have anything before and anything after. So here we have a bunch of t's in front of it, we have a bunch of zeros afterwards, we're good to go. This is true. Let's do another example. So here we have 23.345. Does that match our pattern? And the answer is yes, this is going to be true, because once again, we have a dot, and then we can have any number of characters before and any number of characters after. I didn't specify if they had to be letters or numbers. It can be any characters. So having 2, 3 in front of the dot is perfectly fine. Having 3, 4, 5 after the dot is perfectly fine. Let's try this example, where we have the string dot. And does that match our pattern of star dot star? And the answer is no. So this is going to be false, because we see that there is no dot. The pattern pretty much says, is there a dot in our string? If so, this is going to be true. We see here, there's no dot. Therefore, this is going to return false. Here's another one. This one looks a little odd. We have run.and.walk. Does that match our pattern? And the answer to that is yes, it does. You might think, well, wait a minute. Our pattern has 1 dot. Our string has 2 dots. How does this match? Well, you got to remember what we're saying here with our pattern. We have to have a dot, and then there could be any characters, any number of characters beforehand or afterwards. That does include a second dot. So here, the dot that we're matching could either be the one between the run and the and, or between the one between the and the walk. So like if the dot that we use is between run and, that means run would be part of the first star, and then and dot walk would be part of the second star. Likewise, if we use the second dot as the dot that matches, then run dot and would be part of the first star, and walk would be part of the second star. So sure enough, this does return true. Now let's try this example, where we have the string can, and does that match our pattern of star dot star? And the answer to that is no, because once again, there is no dot in our string. If there were a dot, then we would be good, but since there's no dot, then there's no match. We'll do one more example here. Let's say we have West dot Virginia. Does that match our pattern of star dot star? And the answer is yes. We see that we have a dot, so that part's good. And then we see that West would be part of the first star, and Virginia would be part of the second star. So sure enough, this does return true. We'll now do a couple more examples. Let's say we have this expression. So we have T as a single character, and see if it likes or if it matches the pattern capital A through capital Z. So this is true, and the reason why is if we look at our pattern, we're saying that any character, any single character between capital A to capital Z is valid. So here, what this pattern is basically saying is if our string is a single capital letter, then using the like operator on this pattern is going to be true. Sure enough, our string is a single capital letter, just the capital T, so that's going to be true. Let's do another example. So now we're going to check if capital Z matches this pattern. Well, Z is a single capital letter, therefore it matches our pattern, so this is going to return true. Let's try little t with this pattern. We see that little t is not an uppercase letter, so it does not match our pattern, therefore the like operator is going to evaluate to false. Let's try capital R with this pattern. Is capital R a single capital letter? Yes, it is. So this is going to evaluate to true. Let's try something like this. So we have the string can. Does that match our pattern? And the answer is no, because we do have a capital C, but we have extra characters. Our pattern is a single character, and since our string has more than one character, it does not match our pattern, therefore it's false. Let's try one more example. Here we have West Virginia, all lowercase. And does that match our pattern? It most certainly does not. Because first of all, we don't even have any capital letters. And second of all, we have a lot more than a single character. So this does not match our pattern in any shape or form. Therefore, this is going to evaluate to false. We're now going to do a couple of examples as exercises. So what's going to happen is I'm going to give you an expression that has a pattern and then some variable str. You don't know what is actually in str, and we're not worried about that. But what I'm going to ask you is, when would each of these expressions be true? So we're basically checking, here's the pattern, what type of strings would we have to have in order for the like operator to evaluate to true? So for each one, I recommend you pause the video, work it out a little bit, and then resume when you think you have the answer. So here's our first expression. So we have our string, and we're seeing if it's like the pattern capital A through Z, and then capital A through Z, and then a space, and then 4 pound signs. So I want you to tell me, what type of string would we need to have for this to be true? Well, let's look at what we have here. So we see that we have the range capital A to capital Z first. So that means the first character has to be a capital letter. And then our second character is another range from capital A to capital Z. So we have to have another capital letter. It can be any capital letter. And then we have square braces with a space. And that means the third character must be a space. There's no other option to that. And then the 4 pound signs mean we have to have 4 digits. So our string has to start with 2 capital letters. The next character must be a space. And then the last 4 characters have to be digits. So as long as our string matches that pattern, this is going to evaluate to true. Let's try another example. Let's say we have our string to be like capital C, and then A-E-I-O-U in square braces, and then N. So when would this be true? So what we see here is that the first character in our pattern is capital C. So that means we must start with a capital C. And then we have in square brackets A-E-I-O-U. So that's our vowels. Yes, sometimes Y is a vowel, but here we're going to say Y is not a vowel. So we can have our second character be any vowel, and then the last character has to be an N. So we're saying here that our string must start with a C, and then a vowel, and then an N. Let's try another one. So here we have string, and then like, and then 3 pound signs, and then in square brackets we have a dash and a dot, and then 3 more pound signs, and in square brackets a dash and a dot, and then 4 more pound signs. So when would this be true? Okay, so the 3 pound signs means that we start with 3 digits, and then in square braces we have the dash and a dot. So that means the next character can be either a dash or a dot. It has to be one or the other. And then the next 3 characters have to be pound signs. And then we have the square braces with a dash and a dot, so it has to be a dash or a dot. And then finally we have 4 more digits. So we're saying here that for our string to be true, for this to evaluate to true, our string has to be 3 digits, and then a dash or a dot, 3 more digits, another dash or a dot, and then 4 more digits. So it looks like pretty much a phone number is what we're talking about here. We can use either dashes or dots. Let's do one more example. Let's say we have the expression str like, and then we have Mike, space, and a star. So when would this be true? So in this case, we see that it's the pattern starts with Mike with M capitalized. So we know that it must begin with Mike. And then we have a space, so there must also be a space. And then the asterisk means that we can then have 0 or more characters at this point. So this is saying that as long as our string starts with Mike and a space, we're good. If there's anything else afterwards, that's also fine. If there's nothing afterwards, that's also fine. But our string here must begin with Mike and then a space.